Have you ever wondered where oxygen comes from? Most people think that plants are the primary oxygen producers, but this is not the case. Rainforests are the source of only 28% of our oxygen. So where does the majority of our O2 come from?
You might have noticed areas in the ocean where patches of the water look green. That is because it is full of tiny, delicate organisms in our oceans called phytoplankton. Phytoplankton are one of the smallest creatures in the world. They are unicellular autotrophs, which means they use photosynthesis to make their own food. Yet despite their size, they are basic elements in supporting oceanic life and produce about 70% of the oxygen in the atmosphere.
Phytoplankton are grazed upon by animals such as zooplankton, like krill, small fish, sea sponges, and corals. Even marine animals who do not consume phytoplankton either directly or indirectly consume organisms that eat phytoplankton. Even sea lions, sea otters, whales, and sharks ultimately rely on phytoplankton for their energy.
Phytoplankton can be found throughout the world's oceans, although they generally favor the coast, especially regions of coastal upwelling. What is coastal upwelling? Coastal upwelling is the process of bringing the cold, nutrient-filled water up to the surface. In some areas, such as the coast of California, wind energy pushing on the surface layer of the ocean causes it to flow offshore, and then deep, cold, nutrient-rich water is drawn up to replace it.
But just why are those deeper, cold waters full of nutrients? Well, when organisms die or release waste, it sinks deeper, and as it sinks, it decomposes back into simpler nutrients. This happens below the portion of the ocean that has enough light for photosynthesis, so these nutrients cannot be used by phytoplankton unless some mechanism, such as coastal upwelling, brings them back to the surface layer.
Because of their small size and weak swimming ability, phytoplankton are relegated to be passengers on the ocean currents. In fact, the word phytoplankton literally means plant wanderer in Greek. They can, however, move up and down to some extent in the water column. So how might climate change affect phytoplankton? Well, as ocean temperatures increase, the depth of warm surface layer will increase, like it does along the eastern Pacific during an El Niño, making it more difficult for nutrients to be brought back to the surface by processes such as coastal upwelling.
Also, as atmospheric CO2 increases, the oceans are expected to become increasingly acidic, which will make it harder for some phytoplankton, like coccolithophores, which are a major part of the open ocean phytoplankton, to secrete their calcium carbonate shells. A decrease in phytoplankton abundance will be felt throughout the marine food web, as animals cannot find enough food to eat. Because these animals are not able to adapt quickly enough to their rapidly changing environment, we may begin to see major changes in marine populations. We may see changes in our own neighborhoods as well. Because of the large amount of oxygen that the phytoplankton produce, we might soon find ourselves gasping for breath and fighting for each step we take down the sidewalk.
Thank you for watching!